Hey, this is 6.2, day 2. We are now going to be rotating about the y-axis. And just like what we talked about in the first day, when you are rotating it about a certain axis, you have no choice. If it's rotated about the y-axis, everything has to be in terms of y. So if you've got an equation, you better solve it for x so that you have nothing but y's to plug inside here. Okay? You're going to have the same two options as you had yesterday. You've got the disk method and you've got the washer method. Okay, so a disk method is going to look like when your area is smack dab against the y-axis. So when I rotate it, those would be solid. The washer method, something like this guy. You have your area. When you rotate it about the y-axis, you've got this open area there. So those slices are going to be washers. Now when we are rotating about the y-axis, you're going to make your slices perpendicular to the y-axis. So you're going to be making your slices this way. So when you're thinking about your washer method, this is going to be the right function. This is going to be the left function. Just like when you did area, you were looking from right to left. Okay, so let's get right into our first example. All right, now number 5, when we graph this x equals the square root of 1 plus y, I want you to get in the habit of thinking about what those shapes look like, because when they are with respect to y, you have to know how to graph those. Whenever you have a square root, that means you have half of a parabola. When you are squared, you have a whole parabola. So when I'm looking at this, I know it's going to be a half parabola, and I know I can find those intercepts. So if I put 0 in for x, I know that my y is going to be down here at -1. If I put 0 in for y, I know my x-intercept is going to be at 1. So I know my parabola comes up like this. I have the x equals 0, which is the axis here, and then y equals 3, which is this nice pretty little horizontal line. So the area in question is right here. Well, if I were to rotate this area about the y-axis, look at that area. That area sits directly on the y-axis, so these are going to be nice, pretty little circular shapes. Oh, good grief. You think I'd gotten better at drawing this? Nope. Okay. So it's going to be this nice little solid shape. Okay, kind of like a little Hershey Kiss, but not quite as pointed at the bottom. Yes, I'm making this video in the same day, and yes, I'm still hungry. All right, I digress. So because I'm on the axis, smack dab up against this axis, these shapes are going to be disc. They're going to be solid slices. So when I do my volume, I'm going to start it out the same exact way. I'm pulling that pi out because I want a shot at having a nice, pretty fraction. Okay, I'm going to be looking at your y values. Remember, we found this point in order to graph it. That was at -1. So I'm going from -1 to 3. That's going to give me the height of my figure. And then I'm going from, basically you can look at it as a washer if you want to. You've got your right function down. So when I'm looking at my radius, I'm going this way. Okay, so it's function to the x-axis, to the y-axis, sorry about that. So I've got the square root of 1 plus y squared dy. So I'm still doing pi r squared, okay? It's just that now my circles are laying down and my radius goes from the y-axis out to that graph. Okay, so that's going to be my radius. Those are going to be my radius. Okay, so I've got the graph set up, and remember, if I want to put this in my calculator, I put it in just like I did the other ones because I am set up correctly. You are more than welcome, though, to integrate by hand. If you're going to integrate by hand, then please simplify this. So when I do that and integrate, I'm going to have pi times y plus y squared over 2. and then I put 3 in first, and then the negative 1 in. So I end up with 8 pi. So now we're looking at these circular slices. They're going to be perpendicular to the y-axis. So we're setting it on that y-axis. We're making those slices. They'll all be perpendicular to the y-axis. So look at which way those little circular slices are going. Okay, so number 6. I've left this one ungraphed because I want to make sure we all know how to graph those nice, pretty parabolas. I know this is going to be a parabola because it's got x to the 1 power y squared. That 1, if I put 0 in for y, the x coordinate would be 1, so that means I'm here at 1. My y squared is negative, so that means I'm going to open up to the left. When it's a negative y squared, you're opening up to the negative x's. Okay, positive y squared, you're opening up to the positive x's. And then I have the x equals 0, so it is the y-axis. So my area here is this little guy right here. Now notice that my area sits directly on that y-axis, so when I rotate that, it's going to be a solid figure. It's going to be kind of like a ball bearing, but it's going to be smushed because this is not a semicircle. But it's going to kind of look like that nice solid piece. When I make my slices, I'm going to be making them perpendicular to the y-axis, so that radius is going to be the biggest right here, and then it's going to get smaller from there. Okay. So when I do my volume, I'm going to need to know that point of intersection and that point of intersection. So x equals 1 minus y squared, x equals 0, so I'm looking at where these guys equal each other. Well, you can tell if you take the y squared over, square root both sides, you're going to get that plus minus 1. So when I'm finding the volume, and get in the habit of putting the letter of what you're finding, A for area, V for volume, that way you can keep yourself straight. I've got pi r squared. Well, that radius is going to be out to my function, so 1 minus y squared squared dy. I've got my pi out in front, so I have that base area, pi r squared. My interval goes from -1 to +1. Once again, that takes care of our height. So when I put that in my calculator, I'm going to get my 16 pi over 15. And that would once again be cubic units. So look at your area. If it sits directly on the axis, you are good to go. You have nice, solid pieces. Okay. So this one, when I looked at it, they gave it to me as y equals 2 divided by x, y equals 1, y equals 3, x equals 0. So the shape we're looking at is this guy right here. Now this is kind of deceiving because we have everything that we need. It was easy to graph because everything was in terms of y equals. So when I do my integral, I've got pi times my radius. I know my height is going from 1 to 3, so from 1 to 3. When I go to do my radius, I know that radius is going to be from this function down. But when I go to write it in there, I can't write it as 2 over x. Okay? No. This needs to be in terms of y. In terms of y. It's all about the y-axis this time. So I literally have to take this equation and solve it for y. So if I do that, I'd multiply both sides by x, and then I would divide by y, so I get 2 over y. When I'm writing this integral, and I know you're thinking, well, I get the same answer, they are looking for your process. I am looking for your process. So if it's not all about y's, you're going to miss points from AP Central and from me. So it's all got to be about the y's. You have to have the y variables. I know if you put it in your calculator, you'd get the same answer, but I need to see the setup. The setup is just as important as the answer. When I put that in my calculator, I'm going to get my 8 pi over 3. So very nice. Okay. Our last example for the day. We have, I say the best for last, x equals the square root of cosine of y equals 0, y equals pi over 2. The good news is everything's already in terms of y, so I'm ready to throw it in my integral. The only problem is I don't know what this picture looks like. I know I'm going from 0 to pi over 2, but I don't know what my picture looks like. This is where you actually have to think about some points that you know the answer for. Well, I've got 0, so when I put 0 in for y, the cosine of 0 is 1. And let me just make a little t-chart here for you so you can play along at home. So I'm putting in 0 for y. So then x is the square root of cosine of 0. Okay, well the cosine of 0 is 1. The square root of 1 is 1. So at y equals 0, x is at 1. Well, if I look at the square root, or the pi over 2, when I put pi over 2 in here, that's going to give me the square root of cosine of pi over 2. Well, the cosine of pi over 2 is 0, so that's going to be here. Okay. And then you can pick any other points that you know the answer for. For instance, I know 60 degrees. That'd be pi over 3. Well, when I put pi over 3 in there, I get the square root of the cosine of pi over 3. So that's going to be the square root of 1/2. Well, the square root of 1/2 is somewhere in between the square root of 1 and the square root of 0. And we know that this is going to be a curved little piece because it's cosine. It's not linear. So we know it's going to be some, wow, that is absolutely fabulous. I can even make that better. There we go. That makes me a little more happy. Okay. So bottom line, we get that area. It's a nice little curved piece. So it's going to be like a bundt cake. I'm still hungry. So it's going to be like a little muffin, so to speak. Okay, but it is right up against the y-axis, so it's going to be a disc once again. When I make those little cuts, the radius goes from the x-axis out to that square root of cosine of y. So when I do my volume, it's pi r squared times h. So pi times, I'm going from 0 to pi over 2. My radius is the square root of the cosine of y squared dy. Now, if you want to simplify that, once again, you are more than welcome to do so. So you could write the cosine of y dy, but everything else you got to have. You've got to have the dy, you've got to have your integral, you've got to have this. Now, if you're putting this in your calculator, what must you check before you start the process? Yes, make sure you're in radian measure or you are going to be in a pickle. Gosh, I gotta get something to eat. And that's our last exercise for today. So I'm gonna go eat some dinner and you guys enjoy. And